Yeah, so I'm going to record a video for 11.1 and 11.2. I'm going to go through the examples fairly quickly. I will try to give a quick explanation. And then there is an 11.1 worksheet for you to work on after this. So let's move on to the first example. So if you look at the first one, the question is asking us about what conditions we're talking about with a chi-squared test procedure. Quick note about the chi-square is that we use this when we're working with categorical data. So like grades, for example, it's categories A, B, C, D, and F. The one note I like to make is one of the conditions is different for large counts. You check that all expected counts are greater than 5. Okay, so expected counts we will address in example number 2. For the first question, it says which of the following conditions must be met. So again, that's going to take us to D because we need each observation to be randomly selected first before we move on with our process. For example 2, it says which of the following expressions represents the expected count. So how much can you expect based on what a company or the situation is claiming. So in this one, you'll see that it says that you can expect 10% would be a D, and so that's 10% of our random sample. So that's 0.10 times 90, which is B. Okay. So addressing back to that condition for large counts, you would take the expected counts, so calculate those and assure that they're greater than 5 to satisfy that condition. For example 3, I'm going to jump to the question. It says, for this test, the test statistic has approximately a chi-squared distribution. How many degrees of freedom? So degrees of freedom in this case is explained right here, and that is now the number of categories, since we are dealing with categorical data, minus 1. So in this situation, we have category 1, 2, 3, and 4. So 4 minus 1 is 3. So the answer is A. For number 4, this one's looking at which of the following statements is true about a chi-square distribution. Well, if you go back to your reading, chi-squared is looking at right-skewed data, and if we have right-skewed data, that means that the answer will be D. We are only taking on positive values. So if we look at the first example here, we are looking at a claim from milk chocolate candies, and they're claiming that 13% of them will be brown and red, 14% yellow, 16% green, 20 orange, and 24 blue. Given some data here, we have to decide how are we going to test the company's claim. So let's look at some data that we have here. We have a table that breaks down our observed and our expected count. So observed is like your sample, what we have, versus the expected, which is what we talked about calculating. Here you can look at a side-by-side bar graph, and then we decide clearly there are some differences between our observed and expected. So actually what we're going to look at is what's called a chi-square test statistic. And what this is going to do, it's going to tell you how far apart your observed and expected counts are. So how we are going to do this, we need to look at it by hand. There will be calculator functions that does this for us, but by hand, how you would do this, and you will find this formula on your formula sheet. On the bottom right, you'll see it says chi-square test statistic, and this is the sum of your observed minus your expected values squared over the expected. So algebraically, this is what it looks like, and you'll see I have them color-coded to show the math for each individual color. Once you add all those up, we get 10.180, and that is our chi-square test statistic, which is going to tell us the difference between our observed and expected. Okay, so now we do have a test statistic, so we could calculate a p-value, which is going to work just how we've been used to working with a p-value, being able to reject and fail to reject in comparison to the significance level. But we are not actually going to do that now because we are going to eventually run a chi-square test, and it will give us that p-value all at one time, since we already have talked about how to calculate that p-value. So if you look at the second example here, it says, do these data provide convincing evidence that the company's stated color distribution for all the milk chocolate candies is not correct? So just a quick reminder from your reading, when we're talking about hypothesis for chi-square, you just simply state that whatever categorical data you're talking about, the null or the H sub O or sub 0 is that your population of interest, so in this case our milk chocolate candies, is a correct claim, and then the alternative will just be that it's not correct. So if we look at this in context of this problem, we would say that the company that is stating the color distribution for the M&Ms is correct, and then our alternative will be that the company's stated color distribution is not correct. Okay, and then we need to go through our conditions. So same idea as what we've been doing for a long time. We're telling them what we're going to do. We're going to do a chi-squared goodness of fit test with a significance level of 0.05 if we have the conditions met. So we go through random, and we simply state that there's a random sample of 60 M&Ms. 60 is less than 10% of our M&Ms that we have. And then calculate our expected values and assure that they're all greater than 5. So here are all of our expected values, which were calculated for us in this chart. The next thing we're going to do is our do function. So you're actually going to go into your calculator. So if you grab out your calculator and you're going to go into your stat test function. In the list, you want to go down to letter D and you want the Chi-Square GOF test. That's the goodness of fit test. And you'll see in there that when you hit that, you're going to be asked to list your observed and your expected values in your L1 and L2. Okay, so again, you get there by going back, hit stat, and hit edit on L1 and L2, and you put in these values that we have here. You'll then calculate your degree of freedom, which remember when you're in chi-squared, it's categorical. So it's the number of categories. So right now our categories are color. So it's 1, 2, 3, 4, 5, 6. So 6 minus 1 gives us 5. And then we're going to calculate that. And what you'll see you'll get is your test statistic, which is basically the same as what we got when we calculated by hand. And then here is your p-value. And so if you're writing this on a test, you want to make sure to put all of this information down. Okay, so on a chart, here's what it looks like. Remember, we're working with skewed to the right, chi-squared. That's the way that the graphs look. So our test statistic falls roughly right here, which means this area is our p-value. And then after we get all of this information, we have to make our conclusion. So again, you test your p-value against your significance level. And since our p-value is greater than our significance level, we failed to reject our null. So we do not have convincing evidence that the company's stated color distribution for M&Ms is not correct, okay, because that's not supporting us. So then my question and a function I want you to look at in your calculator is what component of the test statistic made the largest difference in the color distribution. So all you really have to do is just go down to that area of your screen and then use your arrow keys and you'll find these numbers. And basically this is telling you the differences in the color distribution. So what you'll find is it's this one here, and that was yellow that I placed in because I put it in order of the chart that you saw earlier. Okay, and that is the end of the notes for today. So good luck working on your 11-1 worksheet.